Okay, let me share my screen and
Yeah.
start our work. And you're able to see, please let me know.
Yes, now I'm able to see.
Okay, so today we need to discuss about these four topics.
Okay.
Okay, let's start with this. What do you understand from this?
Breaking systems into, okay. Um, Earlier, I think the entire application was one application which is called as monolith application. But today, that is split into different modules and services. So we are breaking down the entire huge program into small modules, whereby one is maintenance will be easy and reusability will be extremely high. So we need not write again and again the code. Write once and use it whenever you want it. So we're breaking down those huge code into small modules, which will be easily maintainable and performance also will improve, and call it only when required. Otherwise, unnecessarily loading is not required. When call it whenever is required is what I can think of in a simple term.
Apart from that, whatever you means explained is a good, but apart from that, what are the advantages we will get there?
Two, that is uh, reusability, which is very important, and maintainability. We are easy to maintain small modules, and then these can be shared across multiple applications and then used it. Uh, that is what we are breaking that into modules and services. Okay, this much. I mean, in a technical, I'm not much aware of all that. But otherwise, breaking down into small modules is nothing but no, for better performance, reusability, maintainability.
Scalability as well.
Sorry, scalability. Yes.
Yes, scalability, reusability,
Reliability.
maintainability, and you can say responsibility ownership.
Mm, mm,
Rather than giving a responsibility to the individual person, hey, you are responsible for all these things.
mm, mm,
We will divide the responsibility into means a single person. Hey, you need to do this. You are
mm,
responsible for, let's say, think about this restaurant
mm,
analogy only.
mm, mm,
Hey, waiter has a specific task.
mm,
Apart from that, he don't need to think about any means vegetables there or not,
mm,
or
mm,
how cylinder is there or not. They don't
mm.
need to care
Yeah,
like that. They have a specific responsibility there.
you're right.
Same like chef,
Correct.
same like you can say receptionist.
Right.
Think about if you give a means everyone, if you give a means everyone is responsible for everything.
Correct.
Then what happened there? He's not able to, you can say, deliver anything perfectly
Mm, mm, mm.
because he need to do everything.
Everything.
Makes sense.
Yes, yes.
So responsibility also means there, and you can say think of breaking this service and component. We are dividing our system into a Lego block.
Mm, mm.
And as you explained, means we can use those services in another application as well.
Yes, yes, yes.
And because these are independent services,
Mm,
so if something is break, some service is break or
mm,
module is break,
mm.
then other will not
Yeah,
stop
only
working.
that will get affected. The rest will keep working.
Yes.
Yes.
So means in that manner, you can think of it's easy for as a system designer, or it's easy for us
Mm,
to, you can say, fix the issue and means me say with the confidence, hey, this
mm,
will not break, our
mm.
system will not break.
Correct, correct.
And we can define our boundaries as well, am I right? Trade-off.
Mm, yeah.
And you can say, what is, you can say, failure cases. We
Mm,
can easily think of in a major
mm,
small
mm.
pieces.
Yeah, right, right.
If we need to think in a big piece of, you can say, where everything we need to do, a
Mm.
single module need to do or single application need to do. It's a hard.
Ah.
Makes sense.
Right.
So same analogy, whatever we need to think of in a real world, we
Mm.
can need to think in a
Okay.
real system means while we are designing a system.
Okay.
It's not new. It's
Mm.
the same thing, but we need to analyze this
Ah,
thing or think in a simple manner.
right.
Am I right?
Right.
So now responsibility driven design. What do you understand from this?
Like just now what we discussed, each one owns responsibility for example, a module. So the entire thing is owned by somebody, some entity, and they're responsible for the working of it or scalability of the improvements of it. Is what I can think of in a plain term, responsibility driven design. For example, payment module, if you take, yes, someone owns that payment module. Uh, they are responsible for the workings of it, all that. So he owns it. And then he attaches it to the other modules, thereby where the whole entire application comes alive. So this is what is I can think of responsibility driven design.
So if you talk about when our decision are influenced from a responsibility,
Mhm.
then it's called responsibility driven design factor.
Oh, okay.
Driven mean if you break down these two words,
Ah,
then you understand.
okay.
When it's influence, design is influenced from a this responsibility. We are focusing on a responsibility,
Huh.
like a restaurant app.
Ah,
So cashier is responsible for handling payment.
right.
Makes sense? Or
Right.
cashier or accountant.
Mm.
Am I right? They have a
Right.
different responsibility.
Mm.
And you can say procurement department have a different responsibility.
Correct.
Whatever they need to purchase or do that, they can do. Makes
Mm.
sense?
Mm.
And chef have their own responsibility.
Correct.
Kitchen staff have a different responsibility.
Correct.
Makes sense? And
Right.
waiter have a different responsibility.
Correct.
And you can say your housekeeping staff have a different responsibility.
Correct.
Makes sense?
Right.
So when we will first think about our responsibility
Ah,
and then think about our design, how these responsible will be catered,
correct.
then that's called responsibility driven design.
Okay.
Okay.
Right.
And so that means same thing. We are whatever we learn in our first day, we are repeating the same, but in an incremental manner.
Okay.
Makes sense. So
Right.
everything is a linked
Mm.
and it's a chain or
Mm.
sequence.
Right.
So right now means in a responsible this ownership as if you are giving a responsibility, the ownership should be there,
Mm.
and we will ask if something is not on place for this cleanness, then we will talk with the this housekeeping staff. Am I right?
Yes.
If there is a you can say delay in a you can say order, then we need to check with chef and this kitchen staff and waiter. Am
Correct.
I right?
Right.
If there is a problem with cash or accounting, then we will check with the accounting department.
Correct.
Means with this manner as well,
Mm.
means we can point out.
Correct.
We can rather than pointing out whole team, we will point out a particular means teammates or area which is not working well.
Yeah.
Makes sense?
Yes.
Because this is not good. Hey, means someone means rather than pinning a point or pinching everyone for mistake,
Ah,
we need to pinch or means find means pinch who done that,
yeah, correct.
who is responsible.
Who is responsible?
Makes sense.
Yes.
So, but in a real life person are following same thing. If
Mm,
let's say I will, you can say cheat you. Makes
mm,
sense.
mm,
Let's say in context of money or in terms of commitment.
mm, mm,
Then what people normally do, they will stop believing
mm.
on another person as well.
Okay.
Am I right or wrong?
You're right. You're right. Correct. Correct. Correct.
But rather than this, why they are not doing that? Why
Mm,
they are not leaving that person only
correct.
and don't doubting on other person?
Yeah.
That's also biggest mistake which we
Mm,
are falling.
correct.
Am I right or wrong?
Yes, you're right. You're right. Yes.
Because in that manner you are, you can say, reducing your scope,
So yeah, yeah, right, right.
which is not good thing.
Yeah, correct. No.
Am I right?
Yes, yes.
Okay, now what is next? Stateless versus stateful component. What do you understand from stateless and stateful and component?
Stateless and stateful. Okay, I don't know whether it's correct or not, but in a very plain term, I can think of an analogy like this. Stateless means in a binary operation, we say 0 is stateless and 1 is stateful. Uh, True or false is stateless and true is stateful. Or in a drop down, if I select an item that is stateful, if it is not selected, it becomes stateless. So this is what I can think of, but in a true terms, I don't know what is
So,
stateless.
whenever you not understand, you can say this. You can divide this into parts. Okay.
Ah,
So, what do you understand from state? What is your state? What is your state in technology? What is your state in your
ah.
company?
For example, as I told, okay, on or off. For example, on or off is the state of say uh, a switch. What is the state of the switch? Currently, it is off. When you put it on, it is in on condition. That's the state of that switch or bulb. If you take bulb, it is either on state or off state.
So means state means particular at a time,
Ah,
means what is the condition, what are the means state of that particular object. Am I
mm,
right?
mm.
So if means object is retaining their state and memorizing a state,
Mm,
that's called stateful.
mm.
Makes sense.
Okay, okay.
Think of if you remembered
Ah,
whatever you covered,
mm.
then you are a stateful.
Okay.
But if you are means if you are forget everything
Mm,
and starting from a fresh,
mm.
then it's a stateless.
Stateless.
We are not memorizing anything.
Correct.
Makes sense.
Correct.
So in that simple term, if
True.
means your waiter is memorizing
Right.
what is the previous order
Right.
is given by client
Right.
or customer,
Right.
that's a stateless.
Mm, mm,
And stateful,
mm.
if let's say chef he will cook the deliver the order and forget,
Ah, ah,
it will not need to care means what the previous order is and
ah, ah,
who gave that. No,
ah.
he don't need to care. He need to
Don't
just take that order and deliver. That's finished.
That's all. Okay. Okay.
So that is stateless.
Okay. Okay.
They note means for each and every order is a new order for
New
them.
order for them. Yeah, right.
But for this means let's say as a client, I order first. I will order idli.
Right.
Then means I will order dosa.
Okay.
Then means waiter need to know.
Ah,
Waiter need to know means what is their previous, what I delivered previous, what I need to, what is my new, what is the new order from this customer.
ah,
So
ah, ah.
that he need to memorize. He need to
Yeah.
remember.
Yes.
But chef don't need to remember.
Right, right, right.
Make sense?
Okay, okay, right.
Okay, what is the advantage of this? And what you think? Why waiter is required this? Stateless, stateful. Why chef is stateless? What is the what do you think?
Uh, so as you already mentioned, uh, the chef for him, uh, whatever order has come on the table, he will do that. So then it becomes the moment he completes that order, it becomes stateless. When while doing the order, it is a stateful condition for him, and his work is only that. His work is to prepare the food based on the orders. That's all. He need not worry about the other things. He has to focus only on what order has come on the table, prepare that, deliver it. There the matter ends. He need not worry who ordered it, how many times they ordered this food item, the reviews, all that he's not worried. For him on the table, something is a prepare and then give. That's all.
So you can think of in our pro means our this programs or a project as well.
Hmm, hmm,
Something is we need to adapt the change.
hmm,
If something is changed, we need to update our UI based
hmm,
on change. Am I
hmm,
right?
hmm. Ah, ah,
Then if we are aware of state,
hmm.
what is the previous state, then we can change. Make
Right.
sense?
Right, right, right. Okay, okay.
If you don't know the previous state, how you can say now it's improved or not
Ah,
improved?
ah.
In that case, you need to maintain the state.
Right, right, right.
Okay, but some cases the state is fixed. It's not gonna change.
Ah,
Like your labels
ah.
or your menu card.
Mm,
It's not
mm.
gonna change.
I don't want to change correct.
Make sense?
Yes,
So that's a stateless
right.
means in your form, application form,
Ah,
you have enter email, enter name, enter password. These are labels.
right, right.
Value is gonna change, but these are not gonna change.
Mm,
Make
mm,
sense?
mm, 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 mm.
So we need to know very well what is stateless and stateful.
Okay, okay, right,
Okay.
right.
And let's move to next coupling and cohesion in systems.
Uh, Coupling and cohesion. 1 minute. Coupling and cohesion.
You can take a help from Google. I don't mind. But coupling we already discussed.
Now you discussed, correct.
Cohesion is new for you.
Yeah. Cohesion, in fact, almost that also relates to coupling, that is togetherness, that is uh, one example. Mm, See, cohesion can be now the chef example. If you take uh, that guy, he knows his purpose. That is, his purpose is to prepare the food according to the order. So he is in line with the order, and then he prepares it. Uh, so, so if he's not, when you say it is not, he's not in cohesion means, uh, for example, he's supposed to prepare item, for example, dosa item, but he prepares idli. So he's not in cohesion with the orders. Something has gone wrong. So, but when he prepares what is required, then he is in cohesion with the orders. So I don't know whether his example is correct or not.
So let's discuss about coupling first. What do you understand from coupling?
Okay, that is, see, coupling, what we have come across is tight coupling and then loose coupling, where different modules interact interact with each other. So they are all coupled modules, and then and each one is a independent entity. So they are all loosely coupled. Whenever it's required, they'll couple together, do their work, and then they go independent. So this is the knowledge I can think of in the coupling. Uh, or another example, when the payment is done, the delivery module gets called. So those two are coupled entities. When required, they couple. When not required, they are independent entities. So this is what we can say as coupled.
Yes, like husband wife,
Huh.
tightly coupled,
Yes.
or you can say school and staff is loosely coupled. If
Mm.
school is shut down, then you can say your staff will goes to join another school.
Yeah, correct.
Am I right?
Yes.
And but if I talk about tightly coupled, a school and their department are
Mm.
tightly coupled. If school
Mm.
is closed, department also closed. There's
Huh.
no mean of department.
Mm.
Am I right?
Ah, right, right, right.
So cohesion. So means, as you know,
Mm.
means we will dividing the things in our responsibilities. Am I
Mm.
right?
Mm.
So coupling is a measurement of how things are attached together,
Mm.
dependency on each other.
Okay.
And here in a cohesion is a measurement of uh, means responsibility, a responsibility or relationship
Mm.
between our responsibilities.
Mm. Mm.
Like if we talk about this restaurant analogy,
Mm.
means a waiter will take a order.
Mm.
Am I right?
Yes.
And after this, it will means inform to the kitchen staff.
Yeah.
Hey, we will go with this order. We need you guys need to prepare that.
Mm.
Means in a cohesion, we will measure the this relationship or
Mm.
responsibilities,
Mm.
all the components.
Mm.
So that end of the day means client will enjoy his food and get that food on time,
Mm.
and he will happy with the services and pay to us
Mm.
for his order, his or her order,
Mm.
and join us back.
Mm.
It makes sense.
Yes, correct.
So in a better system design, you need to go with the means low coupling and
Mm.
higher cohesion.
Okay.
Makes sense.
Mm. Mm. Mm.
So, do you have any suggestion, anything which is not clear to you, so that we can discuss theory part?
Ah.
Could we move there, or do you
Ah.
have anything which you need to discuss now?
1 minute. See, can you throw more examples related to systems or our modules with that stateless and stateful component? When you say components, no, that part I think we didn't discuss. Components. When you say,
Components.
ah,
Let's say you have uh, let's say you have a one. Let me do one thing. let's say you have this application, and
Okay.
this is a, you can say, HTML page body.
Okay. Okay.
Makes sense. What you can do,
Ah,
you can do one thing. You can, let's say, let me give you a real example nowadays. So here is a next testing. Okay.
mm,
So what you can do, or what you can think of here, is a, you can say, this. We can write a single file and everything is there.
okay.
It's quite possible. Am I right?
Ah, yes, possible.
Let's
Yes.
say this component. Okay, component. So let's say we are taking a header. With this, I am a header of web page. Okay,
Well,
and we have a footer. Footer. I am a footer. Am I right?
okay.
Or maybe you have a main as well. Main. I am main. Am I
Okay.
right?
Right.
But if you think of, we have a 5 pages.
Okay.
Like similar, we have a 6, 5, 10 pages are there.
Ah.
And in this manner,
Mm.
if you are able to see, we are repeating this thing again and again, again
Again,
and again.
again. Ah, ah, right. Right.
But but if you check this,
Mm.
this is, you can say, content is only changed,
Mm.
but rest of the things are same.
Same. Ah, okay.
Why you are not creating a reusable component?
Oh, okay.
Make it separate so that you can use based on a data.
Ah, 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 ah.
That's called component.
Okay. Okay. Okay.
Or
Got
you can think of a Lego block.
Okay. Okay.
Wherever you require button, you can apply or use a button.
Okay.
Wherever you require this header, you can use header.
Ah, ah,
Just pass the data as per your requirement.
ah.
If,
Okay.
if it's a, you can say, data is not changing there, that's also fine.
Okay. Okay. Okay.
But you have a better control.
Ah, ah. Right. 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 Okay.
Now things are clear. What is
Ah, yes.
component?
Yes. Okay. Okay.
Okay,
Okay. Okay.
let's check this. So decomposing system into components.
Okay.
So this is our topic, main topic,
Okay.
module 4 title.
Okay.
Why this matter?
Mm. Mm.
Most systems fail not because of scale,
Ah.
but because of poor decomposition,
Ah.
unclear ownership,
Ah.
and tight
Right
coupling.
coupling. Okay. Okay. Okay.
So real world problem. Let's check this here. Real world problem.
Ah.
You can say this: one change break 5 services.
Ah.
Slow development,
Production
production bugs.
bugs. Right.
Okay.
Okay.
Real life mapping. User app front end,
Mm.
component front end. If
Mm.
we talk about in a application term,
Mm.
we
Mm.
have a different component. Front end is
Right.
there. You can say API gateway is there. Am I
Right.
right? With the help
Right.
of that, you can place a order
Mm.
service, payment service, delivery service, notification service.
Right.
So you can think of in a real world as well.
Ah.
And even front end have a, you can say, another component like
Ah.
header, footer, and here you can also break down into component.
Okay.
Make sense?
Right. Right. Right.
You can think of you have a family have a two son also have a family, they also
Mm.
have a two sons, so it's a tree kind of.
Ah.
Okay,
Okay, okay.
it's exist everywhere. This decomposition exists everywhere.
Yes.
Breaking system into service module, split system into small independent components.
Right.
Why why real engineering impact? Huge code base, small service. Small without okay, this is with without decomposition with.
Mm.
Huge code base, small services.
Mm.
Hard to scale, independent scaling. Makes sense.
Right.
Team conflict, clear ownership.
Correct.
Okay.
Right, right.
So as you discussed, monolithic system.
Yeah, yeah.
Big application, user logic,
Mm.
order logic,
Mm.
payment logic, delivery logic.
Okay, okay, okay.
Problem, everything connected. One
Mm.
failure, full system
Different
down.
phase. Yes, correct.
Okay.
Right.
And microservices, good. User service, order service, payment service, delivery service, notification service.
Mm.
Order service, you can do one, but if you divide into three more,
Ah,
that's a good.
yeah,
Am I right?
yeah, yeah.
Because here the responsibility is clear, ownership is clear,
Mm.
and have a better control.
Yes,
So here you are able to see it's a tree kind of structure. Am I right?
right,
Meaning independent service, easy scaling. Okay.
right.
Responsibility driven design.
Ah,
Each service is equal one clear responsibility.
okay.
There is no deviation. There is no mix and match of the responsibility.
Ah,
If there is a deviation or mismatch,
mm.
then there is a conflict.
Right, correct.
Make sense?
Right.
So order service, order life cycle.
Mm.
Payment service, payment processing.
Right.
Delivery service, rider assignment.
Assignment, correct.
Notification service alert.
Alerts. Mm.
Wrong decision, handler handles payment B.
Ah,
Handle
delivery.
C.
Okay.
One service doing everything.
Everything.
Chaos.
Correct.
Okay.
Right.
Confusing.
Right, correct.
Track design, payment service,
Separate.
delivery service.
Delivery
Yes.
service separate. Yes. Okay.
Okay.
Yes.
So same example means rather than you can say means creating a you can say order. You
Mm-hmm.
can means you can do think about you have a same counter
Ah,
for placing a order and receiving order.
okay.
Makes sense.
Right.
So what happened there means if it's a same counter,
Hmm.
then you are serving two things. You are taking order as well as receiving order.
Correct.
At a time, you can do one thing
One
in
thing.
a perfectly manner. Am
Yes,
I right?
correct. Yes, only one thing. Yes.
So if you are serving a order or busy in a delivering a order,
Ah,
then you cannot take a order.
yes.
If you are taking order, you cannot deliver the order.
Yes.
Make sense or not?
Yeah, correct.
That's why it's required.
Ah,
Am I right?
right. You're right.
That's why in this restaurant itself, they have a different counter for
Counter.
ordering
Yeah.
where they will responsible take the order and means they receive a payment or collect
Mm,
a payment.
right.
And another, you have another counter from where you will means submit your that order
Mm,
and they are responsible to deliver, prepare and deliver.
correct.
Makes sense?
Right.
And there as well have a sub you can say this module.
Mm.
Someone are just responsible serving the order. Some
Mm.
are responsible preparing the order.
Correct.
Some are just responsible for transferring your order from one place to other.
Other place, yeah.
So as I told you, you are not learning new.
You,
You are learning which is already exist. Just you earlier you are not thinking like that way. Now I am giving you a thinking you so that you can think system design in everything. Am I right or wrong?
You're right, you're right. It's already in place. Everything, the only thing we're trying to map now, that's all.
Yes, you can think anything because
Mm,
if some problem come to you, like you are thinking right now, this boutique app,
mm,
boutique online business,
mm.
everything is same.
Yeah, yeah.
Maybe tomorrow means your one shopkeeper come to you or property dealer come to you.
Mm.
Basic things are same.
Same, yes.
Am I right?
Yeah, yeah.
Just you need to think how you can break down.
Correct.
How whatever you learn, how you can apply those techniques there. That's the only part where you need to practice.
Ah,
Am I
okay.
right?
Okay, yes, you are right.
So now you are aligned with me.
Yes.
Earlier, maybe you have a doubt, Deepak is what Deepak is saying.
No.
State,
Ah,
stateless versus stateful
grateful.
component.
Yeah, right. Yes.
So here, stateless, no memory between a request,
Because,
maintain states.
right.
So login API stateless,
Mm.
order tracking stateful,
Full. Yeah, right.
payment API stateless,
Yes.
delivery workflow stateful.
Grateful.
Sridhar means right now what which approach you are following is a good or we need to change because first we will do a discussion.
Ah,
Am I right? Then we will come to a theory. We can do vice versa. It's totally up to you.
No, no. This method is okay. Whatever method you're following now, that is ideal. It's okay. We need not change the system. It's ideal only.
Okay.
Yeah.
So here stateless flow.
Ah,
Client request API means take that request,
mm.
database check that request, response send back to API and API send back to client.
Client, yes.
They forget everything after that.
Yes. Yes.
Okay. They
Yeah.
don't know what is the previous, what they did earlier.
Ah, ah, ah.
Every request is a new request.
Mm.
Okay.
Right.
Stateful order created, processed, outward delivery delivered.
Mm.
State transition matters.
Matters. Mm.
Engineering rule API stateless, workflows
Stateful.
stateful.
Mm.
Okay. Do you have any concern? Anything which is not clear to you?
No, in a very simple terms you're explaining, and the examples are quite very simple. I'm able to relate it. It's okay, fine.
Okay, now coupling dependency between services.
Services, yes.
Internal clarity of responsibility.
Ah,
Okay.
right.
High coupling bad.
Yeah, it
Like
should not be.
order delivery, direct DB access,
Mm,
payment DB.
mm.
Tightly dependency, fragile system.
Mm.
If one is thing is break, then another cannot survive.
Mm.
Okay. Low coupling, order service,
Mm.
API,
Interface.
payment,
Okay.
payment service.
Okay. Ah,
Direct data access is not there.
okay.
Loose connection, flexible system.
Mm.
Cohesion example.
Yeah.
Low cohesion service
Mm.
handles. You can say order, payment, service
Mm.
handle all these things.
Right.
High cohesion, one service, one domain.
Correct.
Okay.
Right.
Okay, real engineering example like which we already discussed.
Ah.
Okay.
Right.
In technical term, we are calling cohesion.
Ah. Ah. Ah.
Order service, order placement
Yes.
event,
Ah.
payment service, delivery service, notification service. No
Right.
direct dependency.
Yeah. Correct.
Independent scaling.
Yes.
Tool used in real system.
Yeah.
Backend services, Node.js, Spring Boot, Gin. Do you know what is Gin?
Backend service one made. Okay. Okay. Uh, in fact, even no, these three are new because I have heard these terms, but among this Node.js and Spring Boot, I have heard. I have seen demo also, but GIN, I don't know. Gin, I don't know.
Gin is a framework
Ah,
of Go for
for
making a
Go.
Golang,
Oh,
Golang,
Go language. Okay. Okay.
and it's used to make a backend
Uh-huh.
API or
Oh,
services.
oh, okay.
It's a framework of Java.
Ah,
It's a JavaScript based or TypeScript based, not
okay.
Go.
Oh, okay.
All are for backend.
Uh-huh. Uh-huh. Okay.
Python have a fast API.
Ah,
Mm, Fast API there. Flask is there,
ah,
and Django is there.
ah.
So these are the, you can say, frameworks.
Frameworks. Oh, okay. Okay.
Communication, as we know this,
Ah,
Apache Kafka, RabbitMQ,
okay.
API layer,
Ah,
REST API, gRP, which we discussed earlier as well.
yes, yes, yes.
Common mistake,
Hmm.
splitting by layer, controller service,
DB.
DB layer. You need to split more, am I right?
Now, okay, here can we go a little in detail? For example, splitting by layers, controller, service, DB. Can you just elaborate more on this?
Like controller, you
Ah,
know MBC, let's talk about MBC pattern.
MVC, correct?
And MBC means model view controller.
Controller, yes.
So one layer is responsible for logic,
Ah,
one is responsible for rendering or view.
okay.
Makes sense.
Ah,
And one is a intermediate person,
okay.
which is help to transfer data from one place to
One.
another.
Right.
It will a middleman.
Hmm.
So you are based on a, rather than splitting the things on a responsibility on thing, you are
Ah,
based on a layer.
okay.
Like this is a controller
Ah,
which will control like
ah,
interface for user. Makes sense.
okay.
With
Okay.
the help of that, you can. It's an intermediate person which
Ah,
will take a input from a user
ah,
from UI
ah,
or anyway.
ah,
Okay, and it will check the request,
ah.
and you can say give to the service. Hey,
Okay.
this request will go.
Okay.
Think of a, you can say your this restaurant analogy.
Ah,
Restaurant means waiter take a order,
ah,
and it will tell the, you can say, kitchen staff, hey, we will go that order.
right.
Am I right? They
Right.
will prepare and give back to the this waiter, and waiter deliver that to the
Ah.
customer. Am I right?
Yes.
So here you can think of, this is a client, is a, you can say, waiter is our controller,
Okay.
and service is your this communication between kitchen by waiter.
Ah,
Means, and it's a service means waiter itself, which is a, you can say, communicating
okay.
user order to a kitchen staff. Am I
Okay.
right?
Okay.
And kitchen is your DB, where everything
Yes.
is stored.
Everything is stored there. Correct.
Okay.
Yes.
So splitting by layer. We are
Ah,
splitting the system with the with the help of layer.
Right.
Make sense?
Right. Right.
Now you understand?
Right. Okay. Got it. Okay. Got it.
Shared database across services.
Ah.
You are shared means everything, whatever you require, you have a single table
Right.
and you are doing the everything there only, which are
Ah.
not
Ah.
good. Am I
Not
right?
good. No, correct. Not good. Yes.
One service doing everything
Ah. Ah. Ah.
means one person is handling everything.
Everything. Yeah. That is not correct. Yes.
Too many tiny services
Ah. Yes.
means you are doing unnecessary thing.
Yeah. Yeah. Correct.
Means wherever responsibility is fine, but overthinking and over you can say if there is no balance, it's a balance between your things is not good.
Not good. Yes. Yes.
No ownership clarity.
Yeah.
Okay.
Right. Right.
How to evaluate good decomposition?
Hmm.
Does each service have own clear role? Ask.
Hmm.
You need to ask this question.
Does each service have one clear job? Okay. Oh, how to, okay. Good decompositions. Okay, fine. Okay, fine. Okay.
Can it deploy independently?
Independently. Okay.
Can it scale independently?
Okay.
Does it avoid direct DB sharing?
Okay.
Does it communicate via API
Or events.
events?
Okay.
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 Real thinking.
Ah.
How do you decompose a system?
System.
Answer.
Okay.
Identifying domains. How you can think
Hmm.
for decomposition.
Okay. Okay.
What are the base you can consider?
Okay. Okay.
Identify domains like payment domain. Okay. Define ownership. Split
Okay.
by responsibility.
Ah.
Reduce coupling. Validate cohesion. Validate cohesion.
Cohesion. Okay.
Make sense?
Yes.
Now, this is a monolith versus microservice.
Right.
Start with a monolith.
Ah.
Move to a services when scale teams grow.
Okay.
Let's say you are going to start a business,
Right.
and that time if you think I require a means a different accountant, different receptionist, then that time you have a constraint with you. Am I
Ah.
right?
Ah. Ah. Ah.
First, you will set up the things and run the system. When means flow is there, you can go with the increment or you go with the scale.
Yes.
Make sense?
Yes. Correct.
So everything have a own importance.
Yeah. Correct.
You cannot think means hey, this is always good.
Yeah. We
No,
cannot think. Yes.
you need to compare.
Yeah. Correct.
That's why this you can say our boundaries are there.
Boundaries are there. Yes.
Okay.
Yes.
Biggest mistake splitting by technical layer instead of a business domain.
Ah.
Okay.
Right.
Now you clearly understand
Yeah. Correct.
that point.
Yes. Yes. Yes.
Final mental model. Break system, assign responsibility, reduce coupling, increase cohesion,
Mm.
scalable architecture.
Right. Right. Right.
To make this scalable architecture, now what you think? It's easy or hard?
It's easier now. If you break the systems, if you're decomposing it, scalability will be very easy.
One line summary. Good systems are built by breaking things into small, independent, well
Yes.
defined components.
Correct. Correct.
Okay.
Yes.
Do you have any question, concern, anything from
Now,
previous lecture, current lecture?
no, tonight I will go through the recording because this is a very important chapter. I will go through the recording after we upload it. Then maybe if anything is there, I can ask in the next class.